Hey Chemsters, this is Mrs. Vandeloy bringing you another episode of Chemster Video. So this section is going to concentrate on how to make a good graph. Okay, hopefully this is review for everyone from your math classes, but let's see how we like to do it in science classes. So Mrs. Vandeloy's rules for good graph making. So number one, always give your title, your graph a title the following form: the dependence of your dependent variable on your independent variable. So what does all that mean? So let's say you're doing a graph where you're studying the effect of temperature on the speed of a reaction. This reaction, you're changing the temperature to known values, so the temperature is your independent variable. Because you don't know the speed of the reaction, the speed depends on the temperature, the speed of the reaction is your dependent variable. So the result of your title will be the dependence of reaction rate on temperature, or something like that. So why, again, tell me why temperature is independent. What do you think? Write that down. Just pause this. Well, welcome back. Hopefully you said something along the line where you are changing the temperature to see the effect it has in the reaction, right? So what is it that you're changing? What is it that you're manipulating? And then why is the reaction rate dependent? Pause this, see what you get, see what I get. Come back. Okay, so let's see how you did. It says you are not initially changing the rate. The rate is determined by the temperature, so that's your dependent. It is dependent on the temperature. Okay, so what else do you have to do? Make sure your x-axis is always your independent variable and your y is always your dependent. So in this case, you would put temperature on the x-axis, which is your horizontal, and you would put your reaction rate as your y, or your vertical. Often temperature is your independent. Your time must be independent if you're graphing that kind of stuff. Always label your x and y axes and give them their units. Here we go. This is important. Never, ever, ever connect the dots in your graph. When you're working in science, you do not connect the dots. Why? You don't have perfect data. It's probably not a big mistake. All right, something you don't have a lot of control over. Errors do occur. But if little things go wrong, they may add up. So you don't want a jig-jagged line. You want a nice straight line. It kind of makes the average of the dots, if you will. It shows you the trend. Okay, so please don't do that. And notice, we are not using bar graphs here. We're doing line graphs. Also, make sure your data is graphed as large as possible in the space you're given. A pet peeve of mine is folks that make itty-bitty graphs on a whole graph paper. All right, spread that data out so you can really see your numbers and what you're doing. It says, so these are your steps to follow if you're going to make a good graph in your chemistry class. I've included some examples of good and bad so you know what they're supposed to look like. So let's go to the next page and see some examples. All right, so I gave you an example of good and bad. So let's scroll down and see why this is a bad graph. Okay, so here it is. All right, and come up with 4 things that are wrong with this graph. Okay, so go ahead and pause this, come up with your 4, and then come back. Okay. All right, welcome back. Well, what's wrong with one of them? All right, is this graph helpful, or this title helpful? No, I don't know what we're looking at. Okay, well, why don't I know what I'm looking at? What's wrong with my axes? Okay, the problem is I don't know what these axes are. They're not labeled. Is it time? Is it temperature? Is it what? I have no clue. So you didn't label your x and your y. So I don't know what x is with units. I don't know what y is with units. One thing that is good about this graph, though, notice that the units are consistent. The x is going up by 10 every time, and the y is going up by 40 every time. That is a good thing. What else is a good thing is taking up the whole room of this area, so that is a good thing. So I've come up with 2 bads and actually 2 goods. What else is bad? All right, look at your data. They zigzagged it. All right, we don't want zigzaggy data. We want nice straight line in there somehow. Okay, so what else is wrong? There is no straight line. So that is my 4. I don't have a title. I don't have labeled axes. I don't have units on my axes. And I don't have a straight line. So those are my 4. How did you do? Okay, let's see what's good about this one. Oh, This is what we're looking at. Look, we have a title, the dependence of the traffic ticket on automobile speed. Okay, cool. I now know what I'm looking at. What else do I have? I have Y and X axis labeled. I know what the X axis is. It's speed. I know what this one's cost. I know what the units are, kilometers per hour. I know it's dollars. What else do I know? I have a straight line. I didn't connect the dots. Oh, that's good stuff. Okay, so let's go on the next page. Something else that's really important in science is to determine a slope. Okay, slope will help us immensely. So I'm hoping this is review from your math class. And to find slope, it's rise over run, or change in y over change in x, or y2 minus y1 over x2 minus x1. So your helpful hint is your graph goes to the origin, use this as a point to solve for slope. So for example, find the slope of a. All right, let me scroll down so I can give you the whole graph. All right, so we need to find the slope of a. I scrolled it down for you. I'm not really telling you what my graph is all about. I'm sorry I don't have my lines or my axes labeled. I don't have a title here. I'm just trying to show you how to do slope. We're going to put all that stuff together a little bit later on. So what was a helpful hint? It says if you can use the origin, please use the origin. All right, so in my red line here, I'm going to use this spot and this spot. That's my origin. It's going to be helpful. So how do I find slope? Well, here's my equation. Y equals mx plus b, or excuse me, y2 minus y1 over x2 minus x1. And here, what's my y2? I use my 6. What's my y1? 0. What's my x2 down here is 8. And then again, my origin, it's 0. If I do the math, I get 0.75. In letter B, I don't have an origin, so I picked 2 points that went through like an axis, or the 2 lines where they intersect. So that really helps out. So here's my equation again. So here my y2 is 6, my y1 again is 0, but now my x2 is 4, my x1 is 1. So I get 6 divided by 3, and hopefully you can do your math, and that's equal to 2. Now here's my C. Again, I can't use the origin. It doesn't go through the origin. So I'm going to plug in this value. My y2 is 7. My y1 is 0. My x2 is 6. My x1 is 0. So that's where these numbers come from. Oops, I think I flip-flopped those, didn't I? Let me fix this. Hang on. All right, sorry about that. I fixed it. So let's try this again. So if my y2 is 7, my x2 is down here at 0. If this is my other point, my y2 is 0, there it is, and my x is 6. There we go. That makes a lot more sense, because what do I get now? I get a negative point, or 1.2. And look at the slope. Look how it goes this direction. That tells me it's a negative. That was my clue. I got my numbers mixed up. So which has a negative slope? Hopefully you got C. Now of the other two, which one is your biggest slope? Hopefully you got B. Why? Because 2 is bigger than 0.75. Oops, that's over here then. And my smallest then is 0.75. It's my smaller number. And look at here. This is like the bunny hill on a ski slope, isn't it? All right, it's a smaller slope. I think maybe Mrs. Vanderwijk could ski down this one. This is a much bigger slope. This is a professional skier's downhill slope, all right, much more steep, so that's a bigger number. Hopefully that helps. Okay, so it's your turn. So construct a graph using the techniques shown above. So you need to put a title in it. You need to put your axes in it. You need to put your lines in it. Don't zigzag them. Okay, so why don't you do that first, pause this, and then we'll do some math. Okay, thanks. All right, so this is the graph I came up with. I have the dependence of distance on time, so my y is dependent on my x. I have my units, my axes labeled, and my units. I tried to spread it out when I was working on this. Unfortunately, if I went anything higher here, if I went like every 5, so 5, 10, 15, 20, 25, I couldn't stick the 28 in there. So I decided to do it this way. It's probably the best I could do at this point. So I guess I didn't give you great data. It's the best I could. So I plotted my points and then plotted a line that looks like it represented those dots the best. So I'd like you to find the slope now. Can you do exactly what I did above and find the slope? So pause this and calculate your slope. All right, welcome back. How'd you do? Well, I put y2 minus y1, and I picked the points 25. It looks like this is 25 and 40. So here's my y2 is 25, my x2 is 40, so y1, x1. And then I went down here. So it looks like my y is 0 and my x1 is 11. Okay, so if you do the math, I got 25 over 29, and if you then do your division, I got about 0.86. So then I want you to find the equation. This is now just like your math class. So find y equals, mx plus b. Let me throw that up here. Okay, y equals mx plus b. So then I plugged in my slope. Well, now what do I need to do? I need to plug in some values. So I just went ahead and used my 10 and my 20. Looks pretty good, all right? You might use a couple other different points and get something very close. And then I'm just going to start doing my math now. Okay, let's see here. I guess this is what I got next. So 10 equals 17.2b. So then I got b is negative 7.2. So then, whoops, that's the wrong one. So here is my equation of my line. Okay, if you use two different points, you'll probably get a tad different number than me. And now it says find the relationship, because again, this is a science class. It's not just y's and x's. Well, what is y? Y is distance. What is x? X is time. So I just substituted the y for what y it is, distance. What is x? Time. So this is the relationship I have between distance and time. I've actually answered, in a sense, my title. What is the relationship between distance and time? Well, this is the relationship. Distance equals 0.86 times time minus 7.2. Let's go to the next page. So what I would like you to do for your homework is to actually complete this page, and then we'll discuss this first thing tomorrow. So go ahead and plot your volume and your mass, all right, and see how you do, all right? Don't wait to be great. Take care. Bye-bye.